Python pals, it's Professor Gallagher, and in this lesson we're going to conquer the very important infinite loop. One of the most famous pioneers of old school rap is Grandmaster Flash. Well, after this lesson, you will be Grandmasters of Flash, because you'll get your Circuit Playground board flashing away non-stop forever as long as it has power. Let's code! And as always, I assume everyone here has completed earlier lessons in the series. If not, here's where you can find everything. Up until now, the code we've written ends after the last line, and on the Circuit Playground, when code is done running, all the lights go off. But sometimes you want code to execute forever. For example, we might want the lights to be on forever. Well, we can keep our code running forever, we just need to use something called an infinite loop. An infinite loop is a portion of your code that will run forever until the power is cut or until a special break key is pressed. Now, most of the time when you write code for maker and electronics projects, you do want to use infinite loops. You want your code to run forever. For example, if you want a light animation pattern to repeat forever, you might also write code that continually runs checking to see if a button has been pressed so you can react to it, or code might constantly run gathering sensor readings so that it can react to some sort of change. Now, the most common way to write an infinite loop in Python is like this. The word while, all lowercase, followed by a space, and the word true with a capital T, and then the line ends with a colon. Now, the while statement in Python checks to see if a condition is true or false, and if it's true, it executes any statements that are indented below the while statement. But by writing while true, we're essentially making the very weird statement, while true is true, which is always true, so that means that the lines that are indented below while true are going to repeat forever. Get to the last indented line below while true, and you jump back up to the first indented line, repeating that loop over and over again. Now, in the future, we're going to see while statements that perform some kind of math in here, which could be either true or false, and the code below the while loop will only execute if that math is true. But almost every program we write is going to have an infinite loop, a while true loop, so let's use that now. We'll light up our Circuit Playground, and we'll keep the lights on forever. So here I am with my CircuitPy board plugged in, and I've launched PyCharm. By the way, if you ever get into PyCharm and you don't see your CircuitPy board on the left-hand side in projects here, you probably don't have it plugged in. You can quit PyCharm, plug your board back in, and then restart PyCharm, and it should show up. Now, I've got my RoyGBiv code here from the prior lesson, but I made a backup copy of this, so I'm just going to edit this code.py code on my board. Now, why don't we replace the first comment so that it says infinite red, because we're going to write an infinite loop that keeps our red light on forever. Now, I'll keep the first few lines in here. I always use these when we're working with Circuit Playground NeoPixels. I'm going to import these 3 libraries, and I'll set up my pixels object to point to the 10 onboard NeoPixels. Now, I want to use red, so I'll keep that, but I can delete everything else because I'm going to write new code. So let's turn on all our lights. You know how to do that. That's pixels.fill, and between parens we'll pass in red. And up until now, we'd been using the time-sleep function for how long we want our light to show up. But to get our red lights to show forever, we're going to use while true. While, space, capital T, true, and end that with a colon. Now, normally what while true does is it will continually execute all the statements indented below it. Well, what statement do we want below this? Well, we don't really want it to do anything. We've already said pixels.fill red. That turns the lights on, so we don't need to do that again. So we can put in a statement that does nothing. That's the statement pass. P-A-S-S, all lowercase. Now let's open the PyCharm terminal and launch TO. Save our work. It might take a second or two. And there are red lights, and they'll stay on forever. So you might wonder, hey, how do I stop this? Well, if you just type Control-C down in the terminal with TO running, you can see our lights go off. We've actually stopped our code, and if you scroll up in the terminal, our terminal window is kind of small, we see a few lines in here we haven't seen before. Trackback most recent call last means this is the line of code that executed when our program stopped running. So this is in the code.py file. It's line 11. If we look up at line 11, that's our pass statement, which makes sense because we're just executing pass over and over again. So that's what happens when you press Control-C. If you make any changes and save them, your code will run again. So before we continue, I'm going to save this file as infinitered.py, then close this window and return to code.py. So why don't we use what we've learned about the while true loop for a quick challenge. This is the Infinite RoyGBiv challenge. Modify the code you wrote for the RoyGBiv challenge. You probably save that as roygbib.py. And take the code that flashes all 7 colors of the rainbow, flash each color this time for only 0.2 seconds, and repeat that cycle over and over again until the board is stopped. And you should save this when you're done, calling it infinite-roy-g-biv.py. The goodness should look like this. I know you're up for the challenge. Why don't you pause, give it a shot, And when you're ready, resume, and we'll take a look at the answer. So I'm going to open my old roygbiv.py file. I'm going to go to File, Open, navigate to my CircuitPython school folder, find roygbiv.py, double-click to open that, and I'm going to highlight all of my colors and my interval variable in here, copy it, then go to my code.py tab, and I can paste this over my definition of red and pixels.fillRed. I don't need those two. And now back in roygbiv, I also want the code to flash the rainbow colors. That's this block of code here, so I'll highlight and copy that. And I want this block of code to repeat infinitely, so I'm going to put it inside the while true loop. I'm going to highlight this pass line because I don't want that anymore, and I'll paste the code I just copied over this. Make sure it's indented. The code under the while true loop needs to be indented. That'll flash each color of the rainbow for my time interval, and it's important to remember we're going to go through all of the lines that are indented under while true. For me, that's line 20 through line 33. Once we hit line 33, we're going to loop back up to line 20 and start this over and over again. It's an infinite loop. It'll run forever until you cut the power or type Control-C. And there's one other thing that I want to point out to you. Occasionally I've seen students write code after an infinite loop. Now, if you outdent code after an infinite loop, like I'm doing here on line 35, I'll write print, we got to line number 35. We're actually never going to get to this line. Everything indented under while true will be repeated infinitely, but whatever's outdented will never be reached. So don't put any outdented code after your while true loop. You'll never get there. In fact, PyCharm has highlighted this with a yellow warning. If you hover your cursor over, it will say inspection unreachable code. Again, another reason why I really like to use PyCharm instead of Moo. It's extra sets of code checks like that can really help out new students. And one more thing I wanted to do, let's change the time interval to 0.2, so it only flashes for 0.2 of a second. Then we can open the terminal. TO is already running. We'll save. Sometimes it takes as many as 5 seconds before the code starts running, but there it is, it's cooking. Look at that, we've got the rainbow flashing over and over and over again. It'll do this infinitely, 0.2 of a second for each color, until we tap Control-C. Or, of course, if we were to cut the power to our board. Make sure you save this to your CircuitPython school folder as infinite-roy-g-biv.py. But Pythonistas, this is more big learning under your belt. You now know how to use the very important while true loop as an infinite loop. You're looking flashy. Keep hacking. There's more big learning ahead so you can continue to make something awesome.